Welcome back to another episode of This Old Compressor. This time our star has taken to producing fireworks and tripping the 20-amp breaker when turned on. I've been patching this thing up for a long time and, well, might finally be time for a new one. I've been wanting a larger, more capable unit for quite some time, but there's always this quiet little fix-it voice in the back of my head that whispers, "Let's give it a try." Well, the old compressor is back on the bench again. This time, the issue is fairly dramatic and potentially dangerous. Those of you that have been around from the beginning may well remember the past issues suffered by this well-used compressor. In fact, as of the making of this video, it's been 725 days since the oil leak and 518 days since the valve and reed replacement. Both of those videos are linked here for your edification. To get a better look at things, I removed the protective shroud using an 8mm socket for the 2 bolts as well as a Phillips screwdriver for the 2 lower screws. I started by checking to make sure the motor spun relatively freely and wasn't seized or bound up. Everything looked fine, which made sense. I wouldn't expect sparks to fly if a seized motor or bearing were the issue. With nothing immediately jumping out at me, I moved on to the main switch. I wanted to check the contacts and make sure nothing looked burned or shorted. With visual inspection checking out there too, it was time to break out the multimeter. At this point, my hunch was that something shorted in the motor windings. Checking the resistance across the hot and neutral leads with the unit switch in the on position, I get about 1.1 ohms, very low but technically not a dead short. When the main switch is turned off, open circuit is displayed, which means the switch is working properly. I assumed I would find a short between one of the circuit legs and ground. To my surprise, I got a reading of open circuit, so the motor coil does not appear to be shorted. To be thorough, I wanted to check out the starter capacitor. Because of the short circuit, the capacitor has been completely drained, but I still confirmed a reading of 0 volts before touching the leads. If you don't know, capacitors can store a very large charge for a long time, even when disconnected from power. This happens to be a 250 volt cap, and touching the leads when fully charged will give you a good zap and potentially kill you. Be very careful. The 100 microfarad capacitor tested a bit on the high side at 119.6 microfarads. That's about 14 microfarads out of spec, but I'm not really too concerned about it at this point, as that would not cause the problem I'm currently having. With the capacitor out of circuit, I did a bit more probing with the multimeter to see if I could find any other reasons for sparks and a tripped breaker. Then I saw it. I don't know how I missed it earlier, but there it was. Bare copper exposed on the neutral line. Once I saw it, it was very obvious what was happening. When the unit is turned on, the motor fan, which is part of the grounded chassis, ate away the insulation from the neutral line that, over the years due to vibration, came in contact with the fan. Once through the insulation to exposed copper wire, an intermittent short to ground would happen every time the fan blade hit the wire. After looking back at this alternative video angle, it was so obvious where the short was. Unfortunately, I didn't have this angle at the time. Having taken this entire motor apart in the past, I wasn't really wild about doing that again. Part of me said, break the whole thing down and rewire everything. If I were doing this on a machine that was not my own, I probably would go that route. But because this is my unit and I know the history, I decided to go for the old good enough fix. I removed the fan to make access easier and began removing the old tired zip ties holding the neutral connection in place. Factory crimp looked serviceable, so I reused the existing insulation sleeve and locked it in place with its own zip tie. With that done, I added a second zip tie to bind that part of the connection firmly to the motor winding so it could not vibrate loose and move around. I used some acetone to clean up the insulation on the neutral lead. I wanted to remove any dirt, grime, grease, or junk that would prohibit electrical tape from adhering to the surface. With the Band-Aid in place, 2 more zip ties were used to, again, lock everything in place and not allow any slack to develop in the leads due to vibration. With everything secure to my satisfaction, I reinstalled the capacitor and motor fan. Test time. No sparks, no tripped breaker. Let's put this thing together and let's get back to work. Well, the old compressor lives to work another day. I'm starting to think if I want a new compressor, I'm going to have to come up with a better excuse. Maybe I should start exploring the idea of, I just want one. Anyway, if you've enjoyed the video, please strike a like and leave a comment. I really enjoy reading your comments and I respond to all of them. So much for this episode of This Old Compressor. See you in the next one in about 600 days. Until then, I'm mainejason. Get out there and give it a try.